day one of using the fundamental theorem of algebra. Sounds so technical. We are going to figure out all the zeros, or all of the x-intercepts, okay, of any given polynomial. So we're going to use the graphing calculator to find easy x-intercepts. If we can find all of them with the calculator, we're going to do it, but don't tell anybody. Divide the original polynomial by that 0 using synthetic division. Okay, we'll get to that. 3 is the big one. Repeat these steps until we reduce the polynomial to a quadratic, something that starts with x squared. Until you get something that starts with x squared, we got to keep doing synthetic division over and over. And then we'll factor it after that, but it'll only be a diamond, so no need to freak out. But here's one thing I will tell you, unless somebody comes up with another way of doing it, in 1 hour they did, in 1 hour they didn't. If you can't factor what's left at the end, we're going to use the quadratic formula. For some of you that still are pondering on the idea if you're going to get this into your brain or not, I will rewrite it here one more time. So if you need it, you have it. The other biggie, you will always have the same number of solutions as the number of the degree. In other words, the largest exponent you see will tell you how many answers there are going to be. And that will be true on all of these. So, let me move this to where we can still see the quadratic formula, and let's give this a shot. Okay, find all zeros of the polynomial function. You must show work. Well, wait a minute. Unless the calculator gives you all the answers. And it may on some of these. And it's awesome when it does. That's why I'm showing you this stuff with the calculator, because if you're not going to use it, well, it's kind of silly to even have the calculator available. So here's what we're going to do. We're going to take whatever the expression is, and we're going to type it into the calculator. This first one, I'm going to get you hooked on this first one, because I'll explain to you how I used to have to do it before graphing calculators, and you're going to be like, oh my gosh. So okay, we get that in. I'm going to hit graph. I just want to look at the picture for a minute. First question. Looking at the expression, how many answers am I going to have? 3. Whatever the degree is, and that's just the biggest exponent, tells me how many answers there are going to be. So there's going to be 3 answers. Now, again, when we're finding zeros, which are the answers, okay, all those are x values when y equals 0. In other words, they're x-intercepts. It's just a fancy way of saying x-intercepts. Oops, and I'm covering them up. Now, here's the cool thing with this. I can look at the screen right now on the graphing calculator and say, okay, it crosses the x-axis there, and there, and there. So I see the 3 answers. Now how am I going to get to them? Well, there's a couple, there's a couple of ways I can do it. One of them, the way I like the best, personally, is if I just bring the table up, if I see any place where y equals 0, the x value is one of my answers. It's one of my intercepts. So, x equals 0. And if I go to where y equals 0, oh, there's another one. 1.
3.
And 3. How many answers do I have? 3. Okay, I'm done.
Easy enough.
Okay. Before the graphing calculator did all these fancy things for us, you would have had to guess and check numbers until you found one that worked for the first one, and then you'd have had to do synthetic division 2 more times. Ugh. No wonder nobody ever wanted to do them. Now, this makes it at least a little bit easier. Now, is this going to happen on every single one? No. Okay? But when it does, be happy about it. So, first one's done. Second one, I'm guaranteeing that's not going to happen again. So, let's try one that's a little closer to reality here. But occasionally you will get some like that. Okay, make sure I type this in right, because lately I've been notorious for typing things in incorrectly. Ruh-roh. Okay, how many answers should I have? I should have 3. How many answers do you see? 1. That x-intercept right there. Now let's get the 1, and then we'll kind of figure out from there what's going on. Okay, what's my 1 x value that I know so far? 1. Because again, where is the y equals 0? Right there. You're like, well, what do I do then? I only got 1 answer. And I mean, I can scroll through here. It ain't coming back to 0 anytime soon. Now what we can do is take that x equals 1, and we can do synthetic division. Don't switch the sign because it's not in parentheses. It's just x equals 1. And then make sure there's no holes. 3, 2, 1, 0. Okay. Just use my coefficients. And we'll kind of do a review here, a Thursday again with synthetic division. Pull down my first term. Multiply. Add down. Multiply. Add down. Multiply. Add down. If you've done this right, if the x value you plugged in here is actually a factor, you'll get no remainder. If you get a number here, something's not quite working right. So let's see here. If we rebuild this like we did before, I start 1 below my old degree, so I start with x squared plus 0x plus 49. Now, when we were doing this before, we would just factor this and we'd be done. Well, it's not quite that easy this time. You're like, why not? Okay, this is x squared plus 49. There's no such thing as a sum of squares. If it was minus 49, that'd be great. This would be easy, but it's not. So I have 2 choices here, and I don't care which one you use, but I'm going to give you kind of the danger of doing the one. So let me show you what I think is the preferable one first, and then the one that you're probably going to choose to do. If I was going to use the quadratic formula, what are my a, b, and c values going to be? B is going to be 0 because there is no x term, and c would be 49. So then, I would go ahead and I'd do negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, when you're doing it with the quadratic formula, if you're going to the calculator, just do the part that's underneath. Don't do it with the square root, because that's probably going to cause most of you trouble. And negative 0, I don't even need that. So somebody can double check and make sure I'm correct here. I got this negative 196.
Wait, you have to... Okay.
So, okay. I have negative 196. Wonderful. What do I need to do when I have a negative underneath the radical?
Pull an eye out.
Pull an eye out. Okay. Can I break down 196? Yeah, it's 14. It's a perfect square. Oh, what if I don't? Well, then, if you're not sure, punch in square root of 196 and find out. So, oops, I don't want that up there. So, plus or minus 14i. Notice no radical over it anymore because it's a perfect square. Over 2. And I can reduce the 14 over 2. Plus or minus 7i. So again, 3 answers. Positive 7i, negative 7i, and 1. 3 answers. I'm done. You're like, now wait a minute, I thought you said there was another way to do this. There is. And I'm going to explain the danger in doing it this way, but I'm going to show you. Here's my other option.
So is that on the x value? Like this plus or minus 7, right?
That's, yeah, those would be my quote-unquote zeros, but you're not going to see an imaginary number on your calculator.
Right.
So that's why we've got to crank it out a different way.
Okay.
My other option would be to take x squared plus 49 and set it equal to 0 and solve it like an equation. Now here's why I don't like this. I could minus my 49 to the other side. And most of you at this point are like, okay, then I'd have to square root it. Here's the danger. A lot of you would remember to take the I out, which would be good. And then you'd be like, the square root of 49 is 7. You would write 7i, and you'd be done. Or you'd come to me and say, well, Hardy, I only got 2 answers. I got 1 and I got 7i. Because people forget the plus minus when they're doing this. Now, if you trust yourself to remember the plus minus part, that's a fine way to do it. I mean, they both get you to the same answer. But if you're one of those that you tend to get yourself in trouble because you forget about things like that, use the quadratic formula. It's still not going to take that much longer. But if you're comfortable using the equation format, go for it. Okay? That's fine. Okay? But this is basically, those two are basically what we're getting ourselves into. Now, to make sure we got this, I got one more of each type on the back. Because like I said, we're not going to do this whole thing right now. We're going to stop on that second half. So for right now, let's knock out number 3 here. Let's get these popped up in the calculator and see what's going on. All right, so x to the 4th. Again, be careful when you're typing this in. 5x to the 3rd plus 5x squared minus 6. 6 to the 4th. Oh, again, see, this is why I have to be careful. I left an entire term out. Okay, is that better? X to the 4th, 5x to the 3rd, 5x squared minus 5x minus 6, yes. Okay, funky lopsided W. Now, I start to look and I'm like, okay, how many answers should I get this time? 4. So let's see. Visually, I see 1, I see 2, I see 3. Okay, I see all 4. Let's hope they're all in the chart. Hey, hey! Okay. What are my 4 answers? What are my 4 zeros going to be? Wherever you see y equals 0, the corresponding x value is an intercept. It's a 0. It's a solution. And if I only find 1 this way, again, I can use synthetic substitution, synthetic division, okay, to find the answers. But do you see how nice that is? Okay. One more. They're like, oh, we're not getting off easy this time, are we? No. 4 answers again. I don't think you're going to see them all this time. Let's find out here. All right, x to the 4th, 6x to the 3rd, 14x squared plus 54x, 45. Okay, let's make sure we're typed in good. Looks good. Yeah, that definitely doesn't look like 4 answers. Looks like I'm going to get 2. That's nice. Definitely not 4, though. So let's see. Where are my answers at? -1. Where? Up there's the other one. Okay. So I have 2 out of 4. Now you may be wondering at this point, well, okay, you have 2 different answers there. Which one do I use in the little box to do synthetic? My answer is it doesn't matter. We're going to get to the same answer at the same time at the end no matter what. So I'm going to use the -1 since I just happen to have it there first. Now I'm not saying we'll have the exact same answer right away, but at the end we will. So let's see, 4, 3, 2, 1, 0. Okay, no holes. All right, so again, bring the first term down, multiply, and add, multiply, and add. Just keep working your way across here. Multiply, and add, multiply, and add. And like we said before, if we've done it right, we're going to get a remainder of 0 at the end. So you're like, okay. So let's see. I started with x to the 4th. So this time I got to start one below that. So x to the 3rd, x squared, x, and 45. And here's where the twist comes in. This is currently not a quadratic. It doesn't have a degree of 2. And that's what I'd mentioned on the front. It has to be a quadratic before we can get to the end. Well, what do I do then? This is where that other x value comes in handy. Because now I'm going to take this. This has now become my problem. And I'm going to use the other x value and do synthetic. One more time. So I'm going to use the -5. If some of you used the -5 the first time, use the -1 this time. You can't use the same one both times. And I'm going to use my coefficients that are down here. Don't go back to the original problem.
Oh, do we include 0 now?
Don't need to include the 0. And we're going to run these guys through. Same process. Just multiplying whatever's down here times what's in the box. And then adding down.
1, 0, 9, 0.
We know both of our factors that we found are correct because we got remainders of 0 for both of them. And since I started with x to the 3rd, now it's x squared plus 0x plus 9. And we're back in the same situation we were on number 2. Because this is really just x squared plus 9. So I have a choice. And again, I don't care which one you use, but just be cautious. If you want to use an equation, you can do x squared plus 9 equals 0. Isolate your x squared term. So you could minus the 9 over. And then take the square root. And as long as you remember your plus, minus, and your I, you can get your 4 answers. Negative and positive 3i.
Every time you use an I, are you going to have a plus or minus, most likely?
Yes, because you're going to be taking a square root and you're going to have a quadratic here. But again, if some of you, that tends to be an issue, remember, you can do the quadratic formula, squared minus 4ac all over 2a, and you'll end up just fine, because here you'd have plus or minus the square root of negative 36 over 2, and after you pull out the I, the square root of 36 is 6, and 6 divided by 2 is 3. It works the same both ways. So here's my game plan with all of this, on why we're not going to do this whole thing right now. What I want you to focus in on are these first 4 problems. They're going to set up just like the ones that we did. Now, the assignment in whole will be on homework check 13 and will be your first assignment. But that's the whole thing. Tomorrow we'll finish the notes and be able to finish the last 3. Why am I only giving you 4? Because A, I want you to have time to be able to graph these and get any zeros you can before you go, before you come in later and tell me I never had a calculator, I couldn't do it. And B, I get this funny feeling some of you may not have gotten real far on your Unit 3 issues packet from Friday, and I want to give you a chance to get that done tonight so it doesn't kill you on the homework check tomorrow. So, take advantage.